All right, AJ, what'd you do for 425? You did 17 times 25? Okay, that's what I did too. And then I stopped. Why? That's a perfect square, right? So our answer is 5 times the square root of 17, right? Questions? All right, what should we do for number 8? Or the 8/11, sorry. Well, remember, we got this, right? What can I pull out of there? I can pull a 2 out of the top, right? So whenever I can simplify first, top or bottom, I do that. So I'm going to rewrite this as 2 radical 2 over 11, or square root 11, and then rationalize it like you guys were saying. How do I rationalize it? What do I multiply by? Thank you. Radical 11, top and bottom, right? Right, so I get 2 out front still, and then I can multiply the 2 and the 11 that are underneath. And then what's the 2 11s make? Square root of 121, which is 11, right? Questions? That's basically what we were doing yesterday. There's a few others where we had addition and subtraction, right? You getting it there, Connor?
Huh?
You getting it?
Yeah.
Okay. All right. All right. So answers to homework. AJ, what'd you get for the first one? I'm picking on you today. 4 times 5, right? So what'd you get? 2 radical 5. Any questions? All right, Taylor, what'd you get for 2?
5 radical 3.
Right. 25 times 3. Mason, what'd you get for 3?
Probably not right. 4.
4, 4?
Yeah, 4 radical 4.
No.
That's what I thought.
4 is right, but what's left? 2, yeah. All right. Cindy, how would you do 27? 3 and 9? What can you do with that 9? Right. So what's my answer? You said the 3 comes out, right? What's there? What do I do with 3 and 2? Multiply. So that's what? 6. What's left? 3. Okay? Nolan?
I'm confused on number 3. I pulled out 2 and 4, and 4 is a perfect square, so I did it, and I got 2 radical 8.
Right. Then you got to go 4 times 2 for the 8 and pull out 2 for the 4. Yeah, you just didn't finish. All right, Mr. Collins. What's the answer?
20 radical 3.
Yeah, 20. Okay? I'm just doing it how I would do it. Jordan, what's the answer?
36. I have 36 radical 2.
What'd you say in front of the radical 2?
36.
Well, no. What's the square root of 36?
Okay.
What do you do with that 3 and the 6?
That would be 18.
Yeah, 18. Okay? William, I'm going to do 3 times 100. What's the answer? Good. Landry, I'm going to do 4 times 2. What's our answer?
I don't know. radical one, not right.
Well, now look,
Not two radical four.
well, this 4 becomes a what? It's a perfect square. 2. What do I do with the 2 and the 4 that's already there? 8, yeah. And then what's left? The 2. You guys with me? Questions? Vincent, what do we do here?
Multiply it by 2.
Radical 2, yeah.
Yeah.
So what do we get?
Radical 6. Radical 4. 2.
Right, radical 6 over 2.
Yeah.
All right, Emma?
Oh, you do radical three, multiply.
Good. So what do we get?
Good, radical 50 over
Good. Questions on those 2? So far, so good? Okay. I think that was it for the, no, here's some more. What's the square root of 4 here? We know it's 2, right? So it's just square root of 7 over 2. You don't have to do the radical 4 over radical 4 because you know what the square root of 4 is, right? How about this one?
4.
4 for the top. Then what do I got to do? Multiply by radical 3 over radical 3, right? So, Mr. Berkey, what's the answer?
Would be radical 12 and then.
No. If that was radical 4 times radical 3, it's radical 12. Good. Okay. All right, what about that 49? The 7, right? So do that. You know, make it easier on yourself. Then do what with the radical 3? Okay? Now what I told you guys to do is change this from 2 over 1 to what? I told you to do this, didn't I? What's the new numerator? Negative 6, right? I multiplied by 3, negative 2, to get the negative 6. So it's negative 6 plus 7. Oops. Gotta write my 7 first. Radical 3 all over 3, right? It becomes one fraction then. Okay? Questions? I'll just read off the rest, and if there's any that you want me to go over, we can go over. Number 14, oh, I just write it, I guess. 10 plus, when it's all done, 5 radical 2 over 2. I did that one like I did 13. 15 ends up being 9 minus the square root of 6 over 3. Number 16 ends up being 20 minus radical 15 over 5. Anybody need to see either of those? All right, this one, what's the square root of 16? 4. What's 2 plus 4? 6. 6 fourths reduces to 3 halves, right? What's the square root of 36? 6. So you get 9 halves. Okay? And then the last two, that's a 4 times 5. So that's 2 minus 2 radical 5 over 3. And this is a 25 times 6. So I can pull the 5 out. And get that. Questions? Does that help? Okay. So today we're going to start solving quadratic equations. All right? You guys watch now this new stuff, all right? Okay. Thanks for helping. All right, so here we go. I'll go back to the first page here. So we're going to solve quadratic equations by graphing and using some algebra, and then we won't do any real life ones today, but some word problems we'll do as well, and we'll solve, all right? But we're going to concentrate on graphing and a little bit of algebra today, solving these quadratics. All right, so a quadratic equation in one variable is an equation that can be written in the standard form, ax squared plus bx plus c. And then we set it equal to 0 when we solve these, okay? So you guys know what standard form looks like, all right? A won't be 0, because if a is 0, there won't be an x squared there, right? So a is always going to be a number other than 0, okay? It says a root of an equation is a solution of the equation. So sometimes they'll ask you for the roots of the quadratic equation. They're just asking for the solutions. It says you can use various methods, all right? So we can graph them, we can use square roots, and we can factor them, all right? So we're going to concentrate on factoring and this using square roots today. We'll talk about the factoring more tomorrow. All right, so have your graphing calculators out to help you. All right. So those are what we're concentrating on today, graphing and using square root. All right, so how do we graph something in our calculator? What button do we start with? Y equals. So hit your Y equals button, and then type that in. X squared minus X minus 6. So hit your Y equals button. X squared minus X minus 6. Okay? And then hit graph. And then you should see, what do we call the graph of a parabola? Oops, I just said it. Graph of a quadratic? A parabola, right? Should be a parabola. Which way is it going to open before you even do it? You know A is what? What's the A value of this problem? Positive 1. So which way is it going to open? Up, right? So it should be a U-shaped graph. All right? So X squared. Anybody having issues with their calculator? Oops, I hit the wrong one. I'm having issues. Anybody not getting their graph? Hit zoom 6 if you're not getting your graph. Zoom's at the top, middle, 6. Okay. If you have some little squares on there, a stat plot, if you've got some little squares in there from an old stat plot, hit second Y equals, hit number 4 and enter, and that'll turn all your plots off. And then again, zoom 6 gets you to the basic looking screen for your graph. All right, so Remember, we're saying this equals 0, right? Where is the y value? 0 on our graph. On a graph, where's the y value 0? Connor, where's the y value 0? -2 and 3. Yeah, where it crosses the x-axis is when y is 0, right? So that's what we look for when we do it graphically. We look to see where your parabola crosses the x-axis. Another place to look is hit second graph. That's your table of values. Where do we see the y 0? See the 2 zeros in the y column? Those are our 2 solutions, our 2 roots. Okay? Anybody else having calculator issues? Everybody's graph is showing up?
Ooh, your table is going by 15s. Second graph.
Right, 0, -6 is the what? What's 0, -6? What's that point? What do we call that, Sophia? No. That's the y-intercept. The vertex is a little bit over more. It's close though, Sophia. All right? So, and we already knew the y-intercept was -6, right? On our last test? Isn't the c value the y-intercept? But when we're solving these equations, we're not looking for the y-intercept, we're looking for the x-intercepts, okay? When we solve these by graphing, we want to see where your parabola crosses the x-axis, okay? Questions? All right, you guys try example B. You got to set it equal to what first?
Y.
0.
Yep.
Yeah. All right. So set it equal to 0 first before you put it in your calculator.
I don't know. We were talking about with the set it equal to 0.
No, there on your paper. Rewrite it on your paper so you know what to type in. So bring that 4x to the other side.
What?
So there's a 0 over here.
That's not my type. Am I being honest?
Yeah. Put it in the next box.
I guess.
Yeah.
Where's mine?
There you go. Now that's what you do.
Yeah, I always.
What do we do? Stress and then look at your, go back.
I gotta see if I can. I gotta do a part wash for grass. Because if I can get a line,
This front. You don't. So if you can't see it, maybe.
I'm not trying to. Turns out I'm all 300 or freak out, bro. I'll go to my house.
Yes, sir. What are we getting the zeros, right?
Yeah.
Well, I don't see one.
That only has one. So get your grass.
Which is fine. I use the one to get lined up. I don't have spares.
All right. So when I say set it equal to 0, I want the right side to be 0. So I have to bring the 4x over by subtracting it, right? So put it in standard form, the 4x goes in the middle because the -4 is my b value, right? My a value is what? -2, right? So before I even graph this, I know it's going to open down, right? And then my b value is -4, my c value is -2. So what's my y-intercept? -2, right? So again, there's some things you should already know what's going on from what our previous chapter, right? Kind of have an idea what it looks like and that kind of thing. So when I go to my y equals then, and I put -2, remember, here's your negative sign down here at the bottom. Don't use the minus sign, use the negative sign. All right, then hit our graph. What happened? Just went away. Must have been my sleeve hit it. Okay, so there's our graph. Does it hit it in 2 spots? Most of the time there's 2 answers, but does this hit it in 2 spots? No, it only hit it in 1 spot. And that happens sometimes, that's okay. Oops. Let's move this over so we can see. All right, so it only hits in 1 spot, and it looks to me like it's -1. But I always go to my table, second graph, and I look to see if there's a 0 there, which it is. Right here, we have that 0. Caleb? Yeah. All right, so our answer is just -1. All right, there's only one root for this one. Sometimes your parabola will be up here like this, or down here like this. How many answers we got there? None. There'll be non-real answers, and we'll talk about that here in a few minutes. Okay? So, questions on graphing using your calculator, graphing calculator. That's pretty easy, right? Look for where it crosses the x-axis. Go to your table if you're not sure. Okay? And we'll go see how that goes. All right, this kind. What's missing in this quadratic equation? The x part, right? The b value. The b value is actually what? 0. Right? So, what we're going to do when there's no b value, we're going to get the x squared alone. Just like it was x. Like if it was 4x minus 31 equals 49, you know how to get x by itself, right? Well, just treat it like it's an x, all right? So we're gonna do what first? We're gonna add the 31, aren't we? So now we have 4x squared equals 80. Then what? We're gonna divide by 4, right? So we want to get the x squared alone like that, okay? Now, how do I turn an x squared into an x? Well, square root it, yeah. So that's what we're doing when we don't have a b value. We're going to get the x squared alone, then we're going to take the square root of both sides. Now, when we do this step, our answer will always have this symbol in front of it, plus or minus. Don't forget that. The square root of something squared is itself, right? And let's simplify 20, just like we did last night. What's the answer in simplest radical form? 2 radical 5. There's a positive 2 radical 5 and a negative 2 radical 5. There is 2 answers. Most of the time, there's 2 answers to these, the majority of the time. Okay? So, there's no b value, no x. In the middle, like your normal quadratic, you're going to get the squared part alone. And then take the square root of both sides. Okay? Now, what am I going to do first? All right, so what's the first step to get x squared alone? Minus the 9, right? Subtract 9. Then what? Divide by 3, thank you. Now, what's negative 9 divided by 3? Negative 3. All right, so here's the new thing. All right? Because these problems were coming up a lot for these guys way back in the 15 or 1600s. And they said, well, how are we going to solve this? Because we're going to do what step now? Square root. How do you take the square root of a negative? Okay? Up until today, you couldn't. All right? But now, we're going to take the square root. All right? We get x equals plus or minus. Now, when we do this, we're going to think about it as the square root of negative 1 times the square root of 3. There was a mathematician that said, let's make the square root of negative 1 equal to I. They call it the imaginary unit. Okay? And also then, if the square root of negative 1 is I, what's I squared going to be equal to? Like what's the square root of 25? 5. What's 5 squared equal? 25. So if the square root of negative 1 is I, what's I squared equal? Negative 1, yeah. Okay, so that's what they said. So they developed or made this imaginary unit, this I, so they could solve this type of square root problem, the square root of a negative. So whenever you see a negative sign under the radical sign, you're going to put an I out front. Okay? Because the square root of negative 1 is I. Can I simplify the square root of 3? Is there a factor tree I can do and pull out a perfect square? No. So then it just stays like that. So if I were to graph this on my calculator, it won't cross the x-axis. It'll be above or below it. If I go to my y equals and put 3x squared plus 9 and hit graph, you could just see it barely up there at the top. So there's a little parabola up there because the y-intercept what? What's my c value? 9. So it was way up here by 9. It was hard to see, but it doesn't cross the x-axis. So when your parabola doesn't cross the x-axis, it has two non-real or two imaginary answers. Okay? And we'll get into these imaginary, or we call them complex numbers, a little bit later, or more to tomorrow probably. All right, so how do I get the squared part alone here? What's with it? What's on the left with the squared part? 2/5, right? 2/5 in front of parentheses, does that mean add, subtract, multiply, or divide? It means multiply. So how do I move the 2/5 over? Divide by 2/5. Well, when we divide by a fraction, what do we end up doing? Multiplying by the reciprocal, right? So I just multiplied by the reciprocal right off the bat. So I'm going to multiply both sides by 5/2. Because what happens with the 2's and the 5's? They cross out. That equals 1, right? When I multiply reciprocals, I get 1. So all that's left over here is x plus 3, right, William? What's 5 times 5? Thanks, you guys. So 5 times 5/2 is 25/2, okay? Now, what do I do at this point to get rid of that square? Square root, right? Isn't that what we did on the other two? So what's the square root of x plus 3 squared? What's the square root of something squared? Itself. So the square root of x plus 3 squared is x plus 3. Now remember, this is like a problem we had yesterday. We're doing the plus or minus symbol. What's the square root of 25? 5, but the square root of 2 is just the square root of 2, right? So how do I get rid of that radical 2? Right, we got to rationalize our denominator, right? So that's why we were doing that yesterday, because you get a problem that looks like some of the ones we had yesterday, okay? Just practicing simplifying. So I got x plus 3 on the left still, and plus or minus 5 radical 2 over 2. Is x alone yet? No. So how do I get x alone? Subtract the 3, right?
Yeah.
So I've got x equals negative 3 plus or minus 5 radical 2 over 2. Now, you know, if you left it like that, it's okay, but what did we do when we saw something like that yesterday? We made it one fraction, right? So what's my common denominator going to be? 2. Right? So if I make it both 2's, what does the negative 3 become? Negative 6. I just multiply it by 2, right? So what we normally do when we get the same denominator is we make it one fraction. Okay? There's two answers there. Negative 6 plus 5 radical 2 over 2 and negative 6 minus 5 radical 2 over 2. And that's an acceptable answer for these. Okay? So we started out with this 2/5 in front. We moved it over by multiplying by the reciprocal. We got the 25 halves. And we took the square root of both sides, and we got x plus 3 is plus or minus 5, the square root of 25, over the square root of 2. We simplified it and subtracted the 3 over, and then finished simplifying. All right, so it's just, once we got x by itself, it's just a problem like we had last night for homework, as far as simplifying. That's why we practice. Right, Wolf? Right, Nick?
Yeah.
Okay? Questions? Makes sense? All right, there's your homework.
Why are we gonna learn this hard stuff?
Because you're good at it.
Yeah, why are we gonna learn it? Start doing some. I did my homework. I got no question on I thought you had
Right, Spencer?
I asked you 60 minutes ago.
So that was just for,
So did you finish that one, you were working on test and ISR for me? Or that was this one that I did back to you? That's right. You still have another one? Well, let's try to get that done, so you're caught up. And then do some homework so I can give you some points. I know. When I walked into ISR, that's what he was doing. Yeah.
Yo, bro, you gotta play against the Rock now.
I don't want to. How long does it take you to beat days?